Algebra I Honors, Lesson 7.2, Solving Linear Systems by Substitution. So, we did a little graphing, I believe, last lesson. Is there another way to solve y equals 2x minus 3 and y plus 3x equals 2? There is. I know, I gave away the ending. What was I thinking? Write one equation as y equals. Alright, so we already have that. Now, we have a y, so we're going to take this part and sub it directly in there. 2x minus 3, and a good habit to get into is to put it in parentheses, even though you certainly did not need to this time, and solve for whatever's left. In this case, it's x. So 2x minus 3 plus 3x equals 2. Combine some like terms. 5x minus 3 equals 2. Move the 3 over. 5x equals 5. Divide by 5. X equals 1. Now I got to put it back in. So let's put it in the one we just subbed. Y equals 2x minus 3. Plug it in there. 2 minus 3 is negative 1. Let's go all the way back and grab the other one. Y plus 3x equals 2. Y plus 3x equals 2. And if I plug in y equals negative 1 and x equals 1, do I get 2? Negative 1 plus 3, 2 equals 2. Hey, we did it right. It's called substitution. It takes a little getting used to. You might want to pause it. You might want to watch me do it. It's already solved for one of them, so we sub in. This is one of those times where the parentheses is a pretty good idea. So now we distribute. Combine our like terms. Move our 21 over. Y equals 2. Sub it back in. In this case, I'm going for the first one. X equals negative 2 times 2 plus 7. X equals negative 4 plus 7 equals 3. Now I'm going to take this one and sub in the two values I just got. 3 times 3 minus 2 times 2 should equal 5. 9 minus 4 indeed equals 5. What I would recommend at the end, I did not do it up here, and probably should have, is that you write down your solution as an ordered pair. 3, 2. And boy, do I get a lot of 2, 3s. Don't do that. The reason I get that is you solve the y first. Oh, that must be the first one. No, it's an ordered pair. X, y. So, keep going. This one you should definitely pause and try. What just happened? Well, if you remember when we were graphing, sometimes they don't solve, and 1 never equals 5. So this is a no solution. This is parallel lines. I believe they call this an inconsistent system. I want to make sure of that before I say that. inconsistent system. Do I care? No, no solution's good enough for me. Try another one. I guess I'm getting inconsistent down here. 6x minus 2 times, sub it in, 3x plus 2 equals negative 4. 6x minus 6x, minus 4 equals negative 4, minus 4 equals negative 4. Well, minus 4 does equal negative 4, so these are actually the same lines, so this is a same line. There are an infinite number of solutions, even though there are not any solutions. They have to fit the line, but there's an infinite number of them. We call this dependent and consistent. And that's what I'm going to get into down here. Both lines intersect. One solution, we call it independent. And it's a consistent system. If the lines are the same, there's infinitely many, but again, not just any old solution. There are an infinite number of them. But we call that, holy mackerel, nice spelling, huh? We call them dependent, but also consistent. Meaning we can get an answer, but there's an infinite number of them, so they're all dependent on each other. In this one, we just call it an inconsistent system, so I'm not sure why I have. I should keep that. An inconsistent system. That's really it. No solutions. I guess that's what I meant. We meant to say no solution. No, I already wrote no solution. So, like I always say, good luck and happy mathing.